Regenerative agriculture is a conservation and rehabilitation approach to food and farming systems. It focuses on topsoil regeneration, increasing biodiversity, improving the water cycle, enhancing ecosystem services, supporting biosequestration, increasing resilience to climate change, and strengthening the health and vitality of farm soil. Regenerative agriculture is not a specific practice. It combines a variety of sustainable agriculture techniques. Practices include maximal recycling of farm waste and adding composted material from non-farm sources. Regenerative agriculture on small farms and gardens is based on permaculture, agroecology, agroforestry, restoration ecology, keyline design, and holistic management. Large farms are also increasingly adopting regenerative techniques, using no-till and/or reduced-till practices. As soil health improves, input requirements may decrease, and crop yields may increase as soils are more resilient to extreme weather and harbor fewer pests and pathogens. Regenerative agriculture mitigates climate change through carbon dioxide removal from the atmosphere and sequestration. Along with reduction of carbon emissions, carbon sequestration is gaining popularity in agriculture, and individuals as well as groups are taking action to fight climate change. History origins. Regenerative agriculture is based on various agricultural and ecological practices, with a particular emphasis on minimal soil disturbance and the practice of composting. Maynard Murray had similar ideas, using sea minerals. His work led to innovations in no-till practices, such as slash and mulch in tropical regions. Sheet mulching is a regenerative agriculture practice that smothers weeds and adds nutrients to the soil below. In the early 1980s, the Rodale Institute began using the term regenerative agriculture. Rodale Publishing formed the Regenerative Agriculture Association, which began publishing regenerative agriculture books in 1987 and 1988. By marching forward under the banner of sustainability, we are, in effect, continuing to hamper ourselves by not accepting a challenging enough goal. I am not against the word sustainable. Rather, I favor regenerative agriculture. However, the Institute stopped using the term in the late 1980s, and it only appeared sporadically in 2005 and 2008 until they released a white paper in 2014 titled Regenerative Organic Agriculture and Climate Change. The paper's summary states, "We could sequester more than 100% of current annual CO2 emissions with a switch to common and inexpensive organic management practices, which we term regenerative organic agriculture." The paper described agricultural practices like crop rotation, compost application, and reduced tillage that are similar to organic agriculture methods. In 2002, Storm Cunningham documented the beginning of what he called restorative agriculture in his first book, The Restoration Economy. Cunningham defined restorative agriculture as a technique that rebuilds the quantity and quality of topsoil while also restoring local biodiversity, especially native pollinators and watershed function. Restorative agriculture was one of the 8 sectors of restorative development industries disciplines in the restoration economy. Recent developments, since 2010, indigenous cultures have long been privy to the innate knowledge of many of regenerative agriculture's techniques. These practices have existed for centuries, but the term itself has only been around for some decades, and as of late, has increasingly showed up in academic research. Since the early to mid-2010s in the fields of environmental science, plant science, and ecology. As the term expands in use, many books have been published on the topic, and several organizations started to promote regenerative agriculture techniques. Alan Savory gave a TED Talk on fighting and reversing climate change in 2013. He also launched the Savory Institute, which educates ranchers on methods of holistic land management. Abe Collins created Landstream to monitor ecosystem performance in regenerative agriculture farms. Eric Toensmeier had a book published on the subject in 2016. However, researchers at Wageningen University in the Netherlands found there to be no consistent definition of what people referencing regenerative agriculture meant. They also found that most of the work around this topic were instead the authors' attempt at shaping what regenerative agriculture meant. In 2011, the not-for-profit Malone Institute was founded in New South Wales, Australia, to develop and promote regenerative practices to reclaim land as water retentive areas by slowing the loss of water from land. The members of the institute created a 22-year in-stream project with neighbors over 2 kilometers of Maloon Creek. A study indicates that the outcomes were positive, but relatively unpredictable, and that suitability of ground conditions on site was a key for success. Bottom-up change in the context of Australian regenerative agriculture is a complex set of narratives and barriers to change affecting farmers. A West Australian government-funded survey of land hydration was conducted by the Maloon Institute in June 2022, which concluded that water retention projects supported the regeneration of native plant species. Founded in 2013, 501c3 nonprofit Kiss the Ground was one of the first to publicize the term to a broader audience. Today, the group runs a series of media, farmland, education, and policy programs to raise awareness around soil health and support farmers who aim to transition from conventional to regenerative land management practices. The film Kiss the Ground, executive produced by Julian Lennon and Giselle Bündchen and narrated by Woody Harrelson, was released in 2020. A follow-up documentary, Common Ground, premiered in 2023 and was the recipient of the 2023 Human Nature Award at the Tribeca Film Festival. Not all regenerative systems emphasize ruminants. In 2017, Reginaldo Hazlitt Marroquin published In the Shadow of Green Man with Per Andreasen, which detailed Hazlitt Marroquin's early life as a campesino in Guatemala and how these experiences led him to develop regenerative poultry agroforestry systems that are now being practiced and expanding in the United States and elsewhere. Several large corporations have also announced regenerative agriculture initiatives in the last few years. In 2019, General Mills announced an effort to promote regenerative agriculture practices in their supply chain. The farming practices have received criticism from academic and government experiments on sustainability in farming. In particular, Gunsmoke Farm partnered with General Mills to transition to regenerative agriculture practices and become a teaching hub for others. Experts from the area have expressed concerns about the farm now doing more harm than good, with agronomist Ruth Beck stating that environmental marketing got ahead of what farmers can actually do. In February 2021, the regenerative agriculture market gained traction after Joe Biden's Secretary of Agriculture, Tom Vilsack, made reference to it during his Senate confirmation hearing. The Biden administration wants to utilize $30 billion from the USDA's commodity credit corporations to incentivize farmers to adopt sustainable practices. Vilsack stated in the hearing, "It is a great tool for us to create the kind of structure that will inform future farm bills about what will encourage carbon sequestration, what will encourage precision agriculture, what will encourage soil health, and regenerative agricultural practice." After this announcement from the Biden administration, several national and international corporations announced initiatives into regenerative agriculture. During the House of Representatives Committee on Agriculture's first hearing on climate change, Gabe Brown, a proponent of regenerative agriculture, testified about the role of regenerative agriculture in both the economics and sustainability of farming. In 2021, PepsiCo announced that by 2030, they will work with the farmers in their supply chain to establish regenerative agriculture practices across their approximately 7 million acres. In 2021, Unilever announced an extensive implementation plan to incorporate regenerative agriculture throughout their supply chain. VF Corporation, the parent company of the North Face, Timberland, and Vans, announced in 2021 a partnership with TerraGenesis International to create a supply chain for their rubber that comes from sources utilizing regenerative agriculture. Nestle announced in 2021 a $1.8 billion investment in regenerative agriculture in an effort to reduce their emissions by 95%. Several days before the opening of the 2022 United Nations Climate Change Conference, a report was published, sponsored by some of the biggest agricultural companies. The report was produced by Sustainable Markets Initiative, an organization of companies trying to become climate-friendly, established by King Charles III. According to the report, regenerative agriculture is already implemented on 15% of all cropland. Despite this, the rate of transition is far too slow and must be tripled by the year 2030 to prevent the global temperature passing the threshold of 1.5 degrees above pre-industrial levels. Agricultural practices must immediately change in order to avoid the damage that would result. One of the authors emphasized that the interconnection between human health and planetary health is more evident than ever before. The authors proposed a set of measures for accelerating the transition, like creating metrics for measuring how much farming is sustainable and paying farmers who will change their farming practices to more sustainable ones. Principles. There are several individuals, groups, and organizations that have attempted to define what the principles of regenerative agriculture are. In their review of the existing literature on regenerative agriculture, researchers at Wageningen University created a database of 279 published research articles on regenerative agriculture. Their analysis of this database found that people using the term regenerative agriculture were using different principles to guide regenerative agriculture efforts. The four most consistent principles were found to be 1. Enhancing and improving soil health, 2. Optimization of resource management, 3. Alleviation of climate change, and 4. Improvement of water quality and availability. Notable definitions of principles. The organization. The Carbon Underground created a set of principles that have been signed on to by a number of non-profits and corporations, including Ben & Jerry's, Annie's, and the Rodale Institute, which was one of the first organizations to use the term regenerative agriculture. The principles they've outlined include building soil health and fertility, increase water percolation and retention, increasing biodiversity and ecosystem health, and reducing carbon emissions and current atmospheric CO2 levels. The group Terragenesis International and VF Corporation's partner in their Regenerative Agriculture Initiative created a set of 4 principles, which include progressively improve whole agro-ecosystems, soil, water, and biodiversity, create context-specific designs and make holistic decisions that express the essence of each farm, ensure and develop just and reciprocal relationships amongst all stakeholders, continually grow and evolve individuals, farms, and communities to express their innate potential. Instead of focusing on the specifics of food production technologies, human ecologist Philip Loring suggests a food system-level focus on regeneration, arguing that it is the combination of flexibility and diversity in our food systems that supports regenerative ecological practices. Loring argues that depending on the relative flexibility of people in the food system with respect to the foods they eat and the overall diversity of foods being produced and harvested, food systems can fall into one of 4 general patterns. Regenerative, high diversity, high flexibility, where ecosystems are able to recycle and replenish used energy to usable forms, such as found in many indigenous food systems. Degenerative, high diversity, low flexibility, where people fixate on specific resources and only switch to alternatives once the preferred commodity is exhausted, such as fishing down the food web. Coerced, low diversity, low flexibility, where people subsidize prized resources at the expense of the surrounding ecosystem, such as in the Maine lobster fishery. Impoverished, low diversity, high flexibility, where people are willing to be flexible but, because they are living in degraded ecosystems and possibly a poverty trap, cannot allow ecosystems and resources to regenerate. Loring's typology is based on a principle he calls the conservation of change, which states that change must always happen somewhere in ecosystems, and derives from the second law of thermodynamics and Barry Commoner's premise in that, in ecosystems, there is no free lunch. Practices. Practices and principles used in regenerative farming include alternative food networks, AFNs, commonly defined by attributes such as the spatial proximity between farmers and consumers. Aquaculture, ecological aquaculture, regenerative ocean farming, agroecology, agroforestry, biochar, terra preta, borders planted for pollinator habitat and other beneficial insects, compost, compost tea, animal manures, and thermal compost. Conservation farming, no-till farming, minimum tillage and pasture cropping, cover crops and multi-species cover crops, home gardens to mitigate the adverse effect of global food shocks and food price volatilities, also as a strategy to enhance household food security and nutrition, regrowing vegetables for recycling and sustainable living, keyline subsoiling, livestock, well-managed grazing, animal integration and holistically managed grazing, grass-fed cattle, natural farming, natural sequence farming, organic annual cropping and crop rotations. Perennial cranks to prevent soil erosion, also known as grading banks, and, in parts of Australia, commonly known as Purvis banks, after Ron Purvis Jr. of Woodgreen Station in the Northern Territory. Permaculture design, polyculture, and full-time succession planting of multiple and intercrop plantings. Silvopasture, soil food web. Environmental impacts. Carbon sequestration. Conventional agricultural practices such as plowing and tilling release carbon dioxide (CO2) from the soil by exposing organic matter to the surface and thus promoting oxidation. It is estimated that roughly a third of the total anthropogenic inputs of CO2 to the atmosphere since the Industrial Revolution have come from the degradation of soil organic matter, and that 30 to 75% of global soil organic matter has been lost since the advent of tillage-based farming. Greenhouse gas (GHG) emissions associated with conventional soil and cropping activities represent 13.7% of anthropogenic emissions, or 1.86 pgCY-1. The raising of ruminant livestock also contributes GHGs, representing 11.6% of anthropogenic emissions, or 1.58 pgCY-1. Furthermore, runoff and siltation of water bodies associated with conventional farming practices promote eutrophication and emissions of methane. Regenerative agriculture practices such as no-till farming, rotational grazing, mixed crop rotation, cover cropping, and the application of compost and manure have the potential to reverse this trend. No-till farming reintroduces carbon back into the soil as crop residues are pressed down when seeding. Some studies suggest that adoption of no-till practices could triple soil carbon content in less than 15 years. Additionally, 1 pgCY-1, representing roughly a fourth to a third of anthropogenic CO2 emissions, may be sequestered by converting croplands to no-till systems on a global scale. There is mixed evidence on the carbon sequestration potential of regenerative grazing. A meta-analysis of relevant studies between 1972 and 2016 found that holistic planned grazing had no better effect than continuous grazing on plant cover and biomass, although it may have benefited some areas with higher precipitation. However, some studies have found positive impacts compared to conventional grazing. One study found that regenerative grazing management, particularly adaptive multi-paddock (AMP) grazing, has been shown to reduce soil degradation compared to continuous grazing, and thus has the potential to mitigate carbon emissions from soil. Another study found that crop rotation and maintenance of permanent cover crops help to reduce soil erosion as well, and in conjunction with AMP grazing, may result in net carbon sequestration. There is a less developed evidence base comparing regenerative grazing with the absence of livestock on grasslands. Several peer-reviewed studies have found that excluding livestock completely from semi-arid grasslands can lead to significant recovery of vegetation and soil carbon sequestration. A 2021 peer-reviewed paper found that sparsely grazed and natural grasslands account for 80% of the total cumulative carbon sink of the world's grasslands, whereas managed grasslands, i.e. with greater livestock density, have been a net greenhouse gas source over the past decade. A 2011 study found that multi-paddock grazing of the type endorsed by Savory resulted in more soil carbon sequestration than heavy continuous grazing, but very slightly less soil carbon sequestration than graze exclosure, excluding grazing livestock from land. Another peer-reviewed paper found that if current pasture land was restored to its former state as wild grasslands, shrublands, and sparse savannas without livestock, this could store an estimated 15.2 to 59.9 giton additional carbon. The total carbon sequestration potential of regenerative grazing has been debated between advocates and critics. One study suggests that total conversion of livestock raising to AMP grazing practices, coupled with conservation cropping, has the potential to convert North American farmlands to a carbon sink, sequestering approximately 1.2 pgCY-1. Over the next 25 to 50 years, the cumulative sequestration potential is 30 to 60 pgC. Additions of organic manures and compost further build soil organic carbon, thus contributing to carbon sequestration potential. However, a study by the Food and Climate Research Network in 2017 estimates that, on the basis of meta-study of the scientific literature, the total global soil carbon sequestration potential from grazing management ranges from 0.3 to 0.8 GeT CO2 eq per year, which is equivalent to offsetting a maximum of 4 to 11% of current total global livestock emissions, and that expansion or intensification in the grazing sector as an approach to sequestering more carbon would lead to substantial increases in methane, nitrous oxide, and land use change-induced CO2 emissions, leading to an overall increase in emissions. Consistent with this, Project Drawdown, referenced in the film Kiss the Ground, estimates the total carbon sequestration potential of improved managed grazing at 13.72, 20.92 gigatons CO2 EQ between 2020-2050, equal to 0.46 teropont CO2 per year. A 2022 peer-reviewed paper estimated the carbon sequestration potential of improved grazing management at a similar level of 0.15 to 0.70 GTs CO2 EQ per year. A research made by the Rodale Institute suggests that a worldwide transition to regenerative agriculture can soak more than 100% of the CO2 currently emitted by people. Nutrient cycling. Soil organic matter is the primary sink of nutrients necessary for plant growth, such as nitrogen, phosphorus, zinc, sulfur, and molybdenum. Conventional tillage-based farming promotes rapid erosion and degradation of soil organic matter, depleting soil of plant nutrients, and thus lowering productivity. Tillage, in conjunction with additions of inorganic fertilizer, also destroys soil microbial communities, reducing production of organic nutrients in soil. Practices that restore organic matter may be used to increase the total nutrient load of soil. For example, regenerative management of ruminant livestock in mixed crop and grazing agroecosystems has been shown to improve soil nutrient cycling by encouraging the consumption and decomposition of residual crop biomass and promoting the recovery of nitrogen-fixing plant species. Regenerative crop management practices, namely the use of crop rotation to ensure permanent ground cover, have the potential to increase soil fertility and nutrient levels if nitrogen-fixing crops are included in the rotation. Crop rotation and rotational grazing also allow the nutrients in soil to recover between growing and grazing periods, thus further enhancing overall nutrient load and cycling. Biodiversity. Conventional agricultural practices are generally understood to simplify agroecosystems through introduction of monocultures and eradication of diversity in soil microbial communities through chemical fertilization. In natural ecosystems, biodiversity serves to regulate ecosystem function internally, but under conventional agricultural systems, such control is lost and requires increasing levels of external anthropogenic input. By contrast, regenerative agriculture practices including polycultures, mixed crop rotation, cover cropping, organic soil management, and low or no tillage methods have been shown to increase overall species diversity while reducing pest population densities. Additionally, practices that favor organic over inorganic inputs aid in restoring below-ground biodiversity by enhancing the functioning of soil microbial communities. A survey of organic and conventional farms in Europe found that on the whole, species across several taxa were higher in richness and/or abundance on organic farms compared to conventional ones, especially species whose populations have been demonstrably harmed as a direct result of conventional agriculture. AMP grazing can help improve biodiversity since increased soil organic carbon stocks also promotes a diversity of soil microbial communities. Implementation of AMP in North American prairies, for example, has been correlated with an increase in forage productivity and the restoration of plant species that had previously been decimated by continuous grazing practices. Furthermore, studies of arid and semi-arid regions of the world where regenerative grazing has been practiced for a long time, following prior periods of continuous grazing, have shown a recovery of biodiversity, grass species, and pollinator species. Furthermore, crop diversification ensures that the agroecosystem remains productive when facing lower levels of soil fertility. Higher levels of plant diversity led to increases in numerous factors that contribute to soil fertility, such as soil N, Ca, Mg, and C, in CEC and in soil pH. Criticism. Some members of the scientific community have criticized some of the claims made by proponents of regenerative agriculture as exaggerated and unsupported by evidence. One of the prominent proponents of regenerative agriculture, Alan Savory, claimed in his TED Talk that holistic grazing could reduce carbon dioxide levels to pre-industrial levels in a span of 40 years. According to skeptical science, it is not possible to increase productivity, increase numbers of cattle, and store carbon using any grazing strategy, never mind holistic management. Long-term studies on the effect of grazing on soil carbon storage have been done before, and the results are not promising. Because of the complex nature of carbon storage in soils, increasing global temperature, risk of desertification, and methane emissions from livestock, it is unlikely that holistic management, or any management technique, can reverse climate change. Commenting on his TED Talk, How to Fight Desertification and Reverse Climate Change, Savory has since denied claiming that holistic grazing can reverse climate change, saying that, "I have only used the words address climate change, although I have written and talked about reversing man-made desertification." Savory has faced criticisms for claiming the carbon sequestration potential of holistic grazing is immune from empirical scientific study. For instance, in 2000, Savory said that the scientific method never discovers anything, and the scientific method protects us from cranks like me. A 2017 fact sheet authored by Savory stated that every study of holistic planned grazing that has been done has provided results that are rejected by range scientists because there was no replication. Table Debates sums this up by saying, Savory argues that standardization, replication, and therefore experimental testing of HPG, holistic planned grazing as a whole, rather than just the grazing system associated with it, is not possible, and that therefore it is incapable of study by experimental science. But he does not explain how HPG can make causal knowledge claims with regards to combating desertification and climate mitigation, without recourse to science demonstrating such connections. According to a 2016 study published by the Swedish University of Agricultural Sciences, the actual rate at which improved grazing management could contribute to carbon sequestration is 7 times lower than the claims made by Savory. The study concludes that holistic management cannot reverse climate change. A study by the Food and Climate Research Network in 2017 concluded that Savory's claims about carbon sequestration are unrealistic and very different from those issued by peer-reviewed studies. Tim Searchinger and Janet Ranganathan have expressed concerns about emphasis upon practices that increase